So last class or the class before, we looked at a problem like this. Pretend that's centered. So the diameter is 80 millimeters on this side. Let's go 200 millimeters on this side. The distance across here, we're going to go 100 millimeters. Distance across here, we're going to go 50 millimeters. So here's what I want to find. I want to find this distance x. I want to find the area. I want to find the perimeter. And I want you to tell me how to divide this puppy up.
Well, first, I was going to do the diameter.
What do you mean about the diameters?
Find the circumference.
The circumference? Well, the thing is, we don't have a total circumference, but we can find the circumference of the whole circle for each. So we can do that. Circumference of this circle would be pi times 80, which is going to be, what, 251.2? I did 3.14 instead of pi key. Circumference over here is going to be 200 times pi, which is going to be 628.
Yep,
0.3. Okay, what's next?
Get your area of the rectangle.
Okay, we can get the area of the rectangle. If I cut that off, I get the area of that piece. I'll call that piece 1. It's 50 by 100, or 5,000 millimeters squared. Area of both circles. Okay, I'll get the area of this circle here is going to be pi times 40 squared, which is going to be 5,026.5 millimeters squared. Over here, this area will be pi times 100 squared, which is going to be, what, 31,416, we're going to go, millimeters squared. Now what? Careful. I can't just add these to this because I'm missing that little slice of the circle. So we've got to look at it this way. Like this. So we got right triangles on each side. Okay, let's look at this left side first. So I'm just going to look at the upper piece here, this one up here. What do I know about that triangle? So radius is which side? This is actually the radius up here, the hypotenuse. That'll be 40 millimeters. That's the only side that's actually a radius of the circle here. What do I know about this side?
You know that it's 50, 25.
25. It's half of the 50, right? So now I can find this side down here is the square root of 40 squared minus 25 squared. Get back here. .225 millimeters is that distance. And I can find this angle here, which is going to be important. How do I find that angle? Jason over hypotenuse, which will be sine. So we're looking at an inverse sine of 25 over 40. Nope, that'd be sine. Opposite over hypotenuse is sine. Adjacent over hypotenuse would be cosine. 38 over 68, 38.68. It should be sine. It's opposite over hypotenuse.
But aren't you taking the center angle?
This angle right here, this is the opposite side. This is the hypotenuse.
I'm looking at it as the angle by in the center.
This one?
Go up to the circle, yeah.
Right here?
I'm looking at that angle on the bottom triangle.
Even on the bottom triangle, you'd have this side and this side. It's still opposite over hypotenuse.
Right. Okay.
So what we have is both this angle here and this angle here are 38.68. So we're going to double those. 77.36. Now we really don't, 77.36 isn't what we want. What we really want is the angle that goes out here, which is 360 minus that. Which is 282.64. We do, however, want this distance here, which was the 31.225. What's this distance out here? 40, my radius. So I have those pieces, those are leading us up to find x. On the other side, if I do the same thing, I should have everything I need to find x. I get this piece and this piece. So now over on the other side here, I'm going to look at this top triangle here again.
So right in the area we don't have the finishing little part of the circle, right?
Well, what we'll have is we'll have a sector. We'll have a sector of a circle here, and then triangles here.
Oh,
Yep. Okay, so down here on this triangle, what parts do we know? The hypotenuse is the radius of the circle. It's 100 millimeters. This side over here is still 25. That's still just half of the 50 across there. So then we can find this piece down here will be the square root of 100 squared minus 25 squared. That ain't gonna work. Let me try that again. I hit a wrong key and I couldn't get out of it. Try that completely over. There we go. 96.825, it looks like. Millimeters. What else can we find here that we need to know? Perfect. Inverse sine of 25 over 100. We'll do that angle. (14.48 degrees). Now that being 14.48 here, of course we're going to double that because both of these are 14.48. So times 2 is 28.955. Again, we want this angle, so it's going to be 360 minus that answer. So 331.04 degrees is that angle. Now we have all the information we need here. What's this dimension here? (96.825), and this dimension here, 100. So we've got 31.225 plus the 40 plus the 100 in here plus the 96.825 plus the 100 over here. We get a total distance for x of 368.05 millimeters. So there's one of our answers. Now back over here to finish off our area. Piece 2, I'm going to make 2 this triangle here. That triangle is going to be, if I had put both of those pieces of triangle together, so it'd be 50 across here times 31.25 divided by 2. So 31.225 divided by 2. So 780.63, we'll round that to. Piece 3, I'm going to do this triangle over here. Again, I'm going to do the whole one. What are the dimensions on that one? 50 times what? 96.825 divided by 2. Gives us 2420.63. Then we have section 4 over here. Section 4, Josh had us find the area of this whole circle. It's going to be the 5026.5 times that angle of 282.64 over 360. So 5026.5 times 282.64 divided by 360. 3946.36.
Are we going to get a worksheet like class?
And then finally, we're going to look at this piece over here, piece 5, this sector. We found that area, 31,416, times that angle of 331.04 over 360. So 31,416 times 331.04 divided by 360. 28,888.76. And we add all those up to get an area. And what do we get? 18. 23. 16. 23, 30, 41,036.8 or 0.38. It looks like. I don't know why I put a dollar sign on the front of that. Millimeters squared is my area. Does that look right? So that's our area. That's not so bad. Perimeter is actually fairly easy. For perimeter, I have 100 and 100. This arch here is the 282.64 and the 251.2. Which gives us a 97.22. I use the circumference and then the angle. So over here we're going to use the 628.3 and the 331.04. $577.76. $974.98 millimeters appears to be our perimeter. What do you think? More fun than a sharp stick in the eye? Pretend that's a circle. Let's say all I wanted to find out here is how tall this is. These are tangents. Since they're tangents, it only makes sense that I draw in a radius to the tangent and get a right angle. So those each going to be 50 millimeters. What else would I know? I can find, if I cut that across there, it should be straight. It should be flat across there. I can cut this and this like this. From that, I can find some angles. I can find those two angles should be the same. And they'll come from this 1 in 5 aspect ratio here. I flip it around like that, I can actually make a right triangle out of it. So this angle right here, which will be the same as this one, is going to be the inverse tangent of 1 over 5. So 11.31 degrees. And that's a big thing when you have those aspect ratios like this, where you have a vertical and horizontal comparison. You can always use that to find angles. And most of the time you'll need to. So now what we have here is we have that 131, or sorry, that 11.31, which makes this angle here 101.31 on both sides. And then of course we can find this angle here, because what we have here is a pentagon, 5 sides. How do we know what the angle total has to be for that? We do 5 minus 2 times 180. 5 minus 2 is 3. 180 times 3 is 540 degrees, correct? Bless you. Which makes this angle up here, if I do 540 minus 90 minus another 90, minus 101.31 minus 101.31, I am going to get 157, I believe, point 38, I believe. So that's this angle up here. From there now, we can find everything. So what I want to do is I want to leave this as part of what I want you to work on for today. I will give you this hint. You can find this distance across here. And once you find that distance across there, you subtract out the 40 from down here. So then that tells you what these two distances have to be. Once you have those, then you can just kind of fly with it from there. So I want you to finish up that problem. And then I'm going to give you a worksheet to work on.
Did? No, Henry. Oh, really? I can't see. Yeah. Nobody was in there. So they stopped it? Yeah. They only had us out of the building for like an hour.
No, it's still going.
Oh, yeah, that's what
I mean, they were still there. When I left.
Well, a lot of those
Volunteer
fires,
investigating.
they got to find the cause. The insurance company won't let them leave till they find the cause. And then depending on what was burning, the risk of a flare-up, and something like that where it's not extinguishable by water.
Yeah, I think they were just tearing apart the ceiling.
Yeah. They won't leave that scene until they're absolutely sure there's nothing that can flare back up.
They had the lights off. They were still there. Most of the trucks were gone. It was just the one big truck and the battery.
Oh, sure. Just so you know, by the way, there will be a quiz tomorrow. It'll be similar to this problem here. The uneven dumbbell problem.